Welcome back to this module, Review of Caches. In this lesson I will describe how employing multi-level caches reduce the miss penalty component of the average memory access time. This brings us to the first technique that I will discuss to reduce the miss penalty. The first one is to employ a multi-level cache. We want to reduce the miss penalty by multiplying not one, but several cache levels. First, our level cache should be small and fast enough to have a hit time of about, preferably 1, sometimes 2, up to 3 clock cycles. The level 2 cache can then be much larger and it will also be slower, but it's still much faster than main memory. Typical L2 hit times are 10 to 20 clock cycles, but this is still much faster than the latency to main memory, which is in the order of 100 to 500 processor clock cycles. High-end processors, high-performance processors even have a level 3 cache. Brings us to the next question. How do we measure the performance of a multi-level cache? I will illustrate it using an example. Here are my assumptions. I assume that the base cycles per instruction, base CPI, is 1.0 under the assumption that all accesses hit in the level 1 cache. Furthermore, the frequency of our CPU is 4 GHz, meaning a cycle time of 0.25 nanoseconds or 250 picoseconds. Also, the main memory latency is 100 nanoseconds, corresponding to 400 processor clock cycles. And the miss rate in L1, the combined miss rate for both instructions and data, I assume is 2%, which is a reasonable assumption. Then, if we only have an L1 cache, the CPI is given by the base CPI times the miss rate of the L1 times the miss penalty of L1, which is the access time, the main memory latency. If we substitute these numbers, we get 1.0, the base CPI, plus 2%, the miss rate in L1, times 400 equals a CPI of 9.0. Now I'm going to add a level 2 cache. It has, that's the assumption, a hit time of 5 nanoseconds, which is substantial, which is 20 processor cycles. The miss rate is also quite high of L2 and is 25%, which is the number of misses in the level 2 cache divided by the number of accesses to the level 2 cache. Why is it relatively high? The answer is because most accesses will not pass by the level 1 cache. The level 1 cache has exploited most of the locality. Here I summarize again the performance if we only have a level 1 cache and now we add a level 2 cache. Then the CPI is given by the base CPI plus the miss rate of L1 times the miss penalty of L1. The miss penalty of L1 is now not the latency to main memory, but it's the hit time of L2 plus the miss rate of L2 times the miss penalty of L2. If we now substitute these numbers, we see that the CPI is 1.0 plus 2% times 20, the hit time for the level 1, times 25%, the miss rate of level 2 times 400, which is the miss penalty of L2, which is the main memory latency, and this gives us an average CPI of 3.4, and we see that the processor with an L2 cache is faster by a factor of 2.6. This completes this lesson. Thanks for watching. In the next lesson I will describe a second technique to reduce the miss penalty by giving read misses priority over writes. Hope to see you back.